Hello, welcome to Pakibi TV. In this video, I will explain set theory. The basic content is why set theory is necessary in mathematics. There are two important answers, but in this video, I will focus on explaining the first reason. Let's think about this. Why is set theory needed in mathematics? When we learn math in middle and high school, at the very beginning of the curriculum, we learn about sets, set theory. Why do we learn about sets? In fact, we don't often ask such questions, because the content is not too difficult and it doesn't hold much weight in the textbook. But we could think about it in reverse, right? Why do we learn set theory when we don't even know where it is strictly necessary? The initial answer is that there is a field called set theory in mathematics, and it is very important in mathematics. Then the question changes like this: why is set theory important in mathematics? This is the content I will explain in this video. One of the answers is that set theory is the basic language of mathematics. This means that set theory integrates all fields of mathematics. Another reason why set theory is needed is that it added the logic of infinity to mathematics. For this, please refer to this video. Set theory is like the basic element that composes all fields of mathematics. This is as if all complex things in the world are made of atoms. In this analogy, set theory or sets correspond to atoms. Keep this in mind and let's understand it more mathematically. What does it mean to integrate various fields of mathematics in a concrete sense? Mathematics has several fields. For instance, there's a field for calculating numbers and expressions, like this. However, there's also a field studying the laws of shapes and spaces. These are subjects known as geometry. The problem is that although all these subjects are called mathematics, they are quite different from one another. There is one way to integrate them, like this. It is the coordinate plane that neatly organizes this overlapping area. The problem lies here. As explained in the video about Euclidean geometry, as mathematics is a logical system, it's very important that all knowledge is rigorously derived from a few self-evident propositions. This is represented in the mathematical triangle. Therefore, it's important that the top parts of the mathematical triangle align. This cannot be achieved through a coordinate plane. In other words, in its current state, it's not that the various fields of mathematics are derived from the same principles, it's just that they partially coincide. Moreover, what if there's another field of mathematics, like topology, for instance? Set theory integrates all of this. Especially it binds the upper part of the system into one to form a true system of mathematics. That is, the mathematical significance of set theory lies here. Just as Euclid collected mathematical knowledge to create the system of geometry, set theory integrates various fields of mathematics into one system. Let's delve a little deeper into this part now. Looking at the mathematical features of set theory, the concept of set theory is extremely simple. That is, it's about thinking of a collection of certain things. That's the only basic concept. Here, the certain thing is the element, and the collection is the set. Isn't it too simple? That's really the essence. There's nothing more to it. That's exactly what we feel when we learn about sets in textbooks. So, it may even seem boring. Actually, here lies the mathematical power of the concept of set theory. It is simple, yet it can express a multitude of things. Being simple is important here, but that's not enough on its own. If that were the case, it would be useless. It must also have the ability to represent everything. Just like atoms that make up all matter consist of only an atomic nucleus and electrons, set theory, which can represent all mathematical content, is represented by elements and the sets they belong to. Because the concept of set theory is just about elements and sets, the symbol which represents that something is an element of a set is the starting point. Then it's not about elements and sets anymore, but about the relation where a set is included in another set, that is, the introduction of the subset notation. Here, the element symbol has been there from the start and is intrinsic, while the subset symbol is defined by the element symbol, it's something introduced. They are not on the same level. In this way, all concepts in mathematics are iteratively created. Null set, intersection, union, difference, power set, etc. are elements of set theory, and numbers, functions, lines, planes, etc. are all defined by the concept of a set. These contents are explained in detail in books on set theory, but since it's a boring and complicated process, I will just mention that it is so and move on here. In summary, the reason we learn set theory in mathematics is to understand what is the most fundamental concept and language in mathematics, just like it's necessary to know that everything in the world is made up of atoms. Remember that the language of set theory is simple yet expresses everything in mathematics. If this video was helpful, please hit the like button and subscribe. Thank you.